So, hi everyone. I'm super excited to be presenting at the Vector Search Con. Uh, I work really closely with Vector Search myself, and I was really glad to be able to present here on at this conference where there are such a amazing lineup of speakers and presenting different types of topics related to vector search. Because as you know that vector search, generative AI, retrieval augmented generation, and of course these days agentic applications are becoming an extremely important aspect of the entire Gen AI tooling that we are seeing around us. And while there has been a lot of emphasis on how you can run generative AI on computers, on systems, on the cloud, there has not been a lot of talk about how you can also leverage these capabilities on mobile. Now, we have seen that a lot of companies, especially mobile companies, are especially shipping CPUs and GPUs that have AI capabilities or sometimes even AI native hardware. For example, with the Tensor processing unit or the Tensor chip from Google in their Pixel devices, which are really fine tuned to be able to run AI analysis or any type of AI workload on mobile directly. So that means that we can also leverage things like vector search and retrieval augmented generation on mobile. And in this presentation, you'll learn all about that. That why would you actually want to invest in being able to do something like that? We'll discover the use cases, and then we'll also look at some hands-on examples of how you can actually accomplish that. So with that being said, let's officially kick this off. So we'll look at how you can build local first secure generative AI applications where you can leverage things like RAG, vector search on mobile with the help of open source frameworks like Gemma, Onyx, Couchbase Lite. And a very quick introduction about myself. So I'm Shivay. I'm a developer experience engineer at Couchbase. And if you're interested to connect with me, you can connect with me on either LinkedIn, or my handle is Shivay Lamba, or if you are interested to connect on X, you can follow me on How to Develop. Now, we already know that there is a tremendous amount of data that's being created on the edge today. If you look at the total global edge computing market, that is projected to grow all the way from $16 billion to more than $200 billion in the next 7 to 8 years. And there's a good reason for that. One of the reasons why you might want to process data at the edge is A, our smartphones are becoming extremely powerful. There is a closing gap between the entry level laptop and the highest end phones. And sometimes the highest end phones might actually be more powerful than some of the entry level laptops today because we are able to put in a lot more of compute. The chipsets are becoming more efficient. The overall smartphone designs are becoming more efficient to be able to run larger workloads. And that's the reason that why a lot of companies today, like Samsung, all these different smartphone products, like Apple as well, are also able to then push AI features that can run completely on your system's device. Now, whether it's real time translation or it's being able to take a picture of something and automatically being able to identify what's there in that picture, all of those type of AI inferencing can be done completely on the device, which also means that you can run it completely offline. So if you are not connected to the internet, or you happen to be in a area where there's very less internet connectivity, you can still be able to leverage these particular features that can give you offline capability. And there's also reduced latency because you don't have to connect to a server and generate a response and have to wait for it. And it also improves privacy. So if you're trying to run certain use cases or workloads where you don't want to send your precious data to the server, for example, it could be medical data of patients, then you might want to actually process all of that data locally on the user's device itself, and which means that there is increased privacy for the user. Now, one of the ways in which you can accomplish that is by having a framework that can support being able to run those type of workloads. So I'll just also kind of give you a quick overview of the way in which we can actually run things like vector search and also some of the predictive functions directly on databases. If you have use cases where your application might need a local first database, if you're building an iOS or an Android application, then that's where Couchbase Lite comes into picture. So Couchbase Lite is based on the open source NoSQL database platform called as SQLite, which is a really lightweight format of being able to run NoSQL operations. And the great thing over here is that you can also sync your data between the cloud and the edge. So in case you are not connected to the internet, you have an offline first application and you are leveraging that. All of the data that gets saved during that time, once you get internet back, you can automatically sync your data between your server and the mobile. So this way, it always keeps your data in sync. And this particular sync capability is bidirectional. It also provides some additional capabilities, like, for example, you can do peer-to-peer synchronization. So another use case over here with respect to AI could be that, let's say, if you have a very large-scale machine learning model and uh, you want to train it on an edge device, it might actually not be possible because the edge device might not have enough compute. But you could use something like a peer-to-peer sync where you could train smaller weights of the model on individual devices and then sync all of them together to a main device and get all of those weights and take, let's say, an uh, average weight. And this way you'll be able to do distributed machine learning training, or what we also call as federated machine learning. And you also get on-device encryption by being able to actually do that. So the idea is that we will see that how we can leverage all of that capabilities of being able to use an offline first database and how we can use that to store vectors. So of course, we are at Vector Search Con, but a very quick overview of what a vector is. So at its most basic form, a vector is nothing but just an array of numerical values. Given, for example, an RGB value is a vector of three values, all representing individually between zero the values of 0 to 255, the values of red, green, and blue. Similarly, if you take, let's say, an embedding model is this highly specialized AI machine learning model that can take data, whether it's in text, images, audio, video format, and convert them into this huge n-dimensional array of numbers. And these array of numbers represent the real world features of whatever information was passed into that embedding model. So this way, the reason for actually being able to do so is so that we can perform vector search. So once we have converted all of our input data into these vectors, we can represent that vectors in this Cartesian plane. Now, let's say that the user comes in and asks a question about running shoes. Now, one of the issues of traditional full text searches that it only searches on the basis of the exact query that the user has given. So if that exact result also is there in a database, then you will get results. But in case it does not match with the input query, then you'll not get the results. So one of the limitation here is that you have to give exactly the same type of search query that you expect the uh, database to also have. And if you are not exactly remembering that search term, you'll not get the search result. For example, if you don't remember the Nike brand, you'll not be able to get results looking for Nike, right? You cannot just simply say, I'm looking for a pair of shoes that have a Czech brand. But if you are using semantic search or vector search, you will be able to get because you'll be able to get results because in case of vector search, we search for matches based on the meaning of the words and not just purely matching the words themselves, which makes it a lot more easier to be able to get more contextual and relevant search results. So that is why you see that in this example, if my query is running shoes, I get track shoes, cross trainers, trail shoes, because all of them are meant for running. So I'm able to get much more personalized, much more relevant search results as compared to a traditional full text search that fails in case the user does not know the exact search query that they are looking for. So this is the reason that we have really seen vector search really take off in the entire world, and that is why we are having this vector search con. In because of the reason being that we have seen such a huge popularity of this particular tool, which now can also be used for semantic capabilities for agents, for LLMs. And we'll see that now how we can also include this inside of edge devices. So a typical way of being able to like do your vector search queries would be, sometimes there are standalone vector databases like Quadrant, all these different other types of other databases like Pinecone. But a lot of times your traditional databases now can also just store your typical data, but also save that embeddings directly into their database. So here's an example of how you would do that. Of course, I've been saying that why have we touched upon vector search? uh, why to actually run it, or not just vector search, but why to actually run a Gen AI application on the edge. Now, there are primarily three main good reasons for that. So we discovered a few minutes back that why is there so much data being processed on the edge? And we'll just take all of those logic points and apply them for generative AI. So there might be use cases where you're dealing with a lot of proprietary data. For example, it could be healthcare data of patients, and you don't want to send that to an OpenAI server or a Gemini or a Claude, where you never know that what they might actually do with your data. They might use that data for retraining of their models and further improving their models, but you don't want to do that. So you can actually run AI and LLMs today, thanks to the capabilities of open source projects like um, Onyx, WebAssembly, WebGL, and especially on Android, it's like Vulkan. All these different capabilities provide you to run LLMs and also run embedding models directly on device. But also, like you can run with the help of Couchbase Lite, you can also run vector search or semantic search completely in an offline manner. So you can run them on edge applications, irrespective of whether you're connected to the internet or not. Now, by being able to embed and handle searches directly on the device, you're also actually reducing your cloud egress fees because everything is happening on your device. This also means that there will be lower latency. And of course, there will be the data privacy because sometimes if you are running some type of sensitive queries, you don't want to send it to the cloud, which means that now you can run it completely offline. And the capability of being able to sync your data between the edge and the cloud, which means that documents that were created on your local application can also now be synced back to the cloud in case that's a requirement. This might not be necessary in every use case, but for use cases where it might be necessary, you can also then do that. So that's one of the biggest reasons for privacy, for security, why you might want to actually run your edge AI or generative AI on the edge. And here's an example of how you would basically support vector search on the edge. So let's say that you have a bunch of images and you pass them through an embedding model, and then you go ahead and store them inside of a vector store, right? Next, when you have to actually perform the vector search, you give another image and pass it through the embedding model to generate the vectors. And then you pass that vector and perform a vector search, and finally get the list of your similar ranked media items and fetch the most relevant. So in this case, your database will be there on the edge, and your logic to actually perform vector search will also be completely taking place on the edge, even without having to connect to the internet. And similarly, if you are having use cases where you want to do something like a retrieval augmented generation, right? That is also completely possible to actually do that on the edge, because as we saw that embedding models can run very efficiently on the edge, and you can also run LLMs directly on the device. So here's like an example of a retrieval augmented generation search application running on the edge device. In this case, again, your JSON documents or PDFs or whatever you might have is being converted into the embeddings, and the original text and its corresponding embedding or the vector is being stored inside of Couchbase or the database over here. And now, when you give a new search query, you convert that into the embedding and perform the vector search. It passes the relevant data or the context from the vector search and passes that context to the LLM. Now, you could be using a cloud-based LLM, but also an on-device LLM like Gemma, because a model like Gemma is completely possible of being able to run on an Android or even an iOS application or an iOS device. So you can now augment the response of the LLM by providing it that additional context, and it gives you much more relevant search results. And one of the key ways of actually doing this specifically when it comes to Android is with the help of an open source framework called as MediaPipe. So it was originally designed by Google in its research to analyze video and audio data, but now it is being used, or the APIs are being used to run LLMs on Android with the help of the MediaPipe LLM inference API. Now, the way to actually do this on iOS will be there are some inbuilt capabilities to run LLMs directly on iOS as well, thanks to some of the native libraries, and you can also use Onyx as well. So typically, if you have a larger LLM, you will have to convert it into a format like the MediaPipe format, and then it will have to use that toolkit to be support running it on Android. Because as you might imagine, that you cannot just take an off-the-shelf LLM and directly just run it on Android because of the different system architecture. So here you can see that we take a base LLM, we let it convert into the model that it will be possible to run that on Android. So in this case, we are passing it through the LLM inference converter, where it gets converted and it gets converted into a format that can run on Android. Now, setting up the vector search inside of Couchbase Lite is extremely simple. So when you get started, you just have to go ahead and do a couple of things. One is, first of all, create your vector index configuration. So in this case, you first share what is that particular collection in which the embeddings are stored. And then you also provide what is the total number of centroids on which it will go ahead and find the most relevant set of um, so the main reason for creating the centroids is to reduce the search space. So how many centroids have to be created, and then what's the dimension of each and every vector? So it could be as simple as just one dimension if you just have one value, three dimensions if it are three values, but it could be 4096 if you're using a larger embedding model. Usually it's between 5 and 12 or 1024, like those type of dimensions, right? So that's an example of like how you will just set it up. So once you have set up that vector index configuration, then you can run your queries on top. So here an example would be SQL plus query, where we do select unique ID, image vector, and here we see that we are performing where vector match, where we are passing the index value and also our given input vector uh, against which will run the vector search, and then how many search results do we want. So do we want the three nearest neighbors? Do we want five nearest neighbors? So we just define that and we get those results by simply running this into the query. Now, for example, if you're trying to use either Gemini or Gemma, in this case, the example on the right-hand side is that of Gemini. It's again fairly simple. You just define your model class. In this case, I'm using Gemini, so I'll also need a Gemini API key, and it's using the Gemini 1.5 Flash, but you can also now replace it with Gemma. But in case of Gemma, the only main difference would be that the Gemma model will basically exist on the user's device. So instead of like just saying model name equal to this, you'll just have to give the path of the model, like where exactly is the model stored in your application. And finally, you can now combine the response of the vector search from the context. So if you look at the first half where we have chunk use case get similar chunks, that is where we are actually performing our vector search by passing the input query, which was our input vector, and n equal to 5, which means that we are trying to get the 5 top search results from our vector search. And then once you've gotten this retrieved context, we pass it to our LLM. So here you'll see that the input prompt gets replaced with the context, and we pass that to our Gemini remote API, LLM API, and we pass the input prompt and we also pass our context with it so that it can do a RAG operation. So with that in mind, let's have a quick look at how this can be accomplished before we jump into the Google AI Edge. So here I have this particular Android application. First, I will just quickly go ahead and actually run this application for you to see. So I'll close this out and I will open it up. And here, what I'll do is I will go ahead and add a PDF document to this particular application. So let's say that I add this all things open document and I ask it a question. Now, before that, let's also go into my files just to kind of quickly show you what that particular PDF document has. It's just a report of a conference. And here you can see that we talk about Commerce Tools, which is a competitor, right? So if you look here, it talks about a report about a conference and it also talks about competitor presence over here, which is Commerce Tools. So what if we ask the LLM about who is the competitor mentioned in the conference? So we'll go ahead and it performs a vector search. Uh, Now, one thing to keep in mind is that it is actually looking through multiple different types of documents, right? Because it's also going through this financial report of cities. So we might just want to also try to use uh, that particular doc as well. So we can also try to ask it a question through that. So this is a huge financial document for the year 2022. Maybe we can ask it a question such as what was the revenue in the year 2022? So let's go ahead and ask that particular question over here. So we'll go back, we'll ask it the question, what is the total revenue in the year 2022? So it says that the total revenue was uh, $196 million, which comes again from, so I guess like because it is probably taking into account some other type of data, but the use case here is that you can see that what we are seeing over here is that the response being generated from the LLM, it does get this context. And these blobs of text are actually coming from the vector search that we are actually performing. So maybe like if I were to tweak the response or the not the response, but the question, because there must have been some other reference of this particular financial data. So perhaps if I go to some other aspect of my PDF here and probably ask it a question related to that particular part of the PDF, maybe that could we can also try doing that as well. So let's say if I go over here and ask it a question related to, we can ask it, let's say, this particular question that how much amount of money has been mobilized for emerging social finance. So we can ask it this type of question. So let's try that. Um, so how much has been used for social finance in billions? So it does tell us again some values, but of course, uh, it says that the provided text gives us the financial breakdown of global wealth, but it does not talk specifically about social finance. So again, one thing to always keep in mind is that you have to give the relevant type of questions. One more thing I can also try to do here is I'll quickly go ahead and delete this application to remove all of the existing data. And we can also then go ahead and rerun this app to have a fresh bunch of documents that we will upload to this particular document, and then we will embed them, chunk them, and perform the vector search. So in this case, once the installation has completed, we are ready to go ahead and add a PDF. So in this case, we'll just add this one. So you'll see that all of the chunks have been created. So I can ask it a question, when was the conference organized? So you can see that it says that the All Things Open was organized on October 30 to November 2022. So that's a quick overview, but now let's dive into our code base over here. So in this case, let's take a look at our code. So the first thing that I will quickly show you is the place where we are actually performing the vector search. So here is the main area. So initially, we go ahead and create a new database. We go ahead and create a vector search index. We define the configuration here. We define what is the particular collection. And in this case, it's the chunk embedding collection. We define the number of dimensions and the number of centroids. So this dimension is coming from the all men v6 embedding model, which you can find over here, which is this all min6 v6 model, but converted into the Onyx format. And it's running completely offline, right? And then we go ahead and have this function called as add chunk, where the idea is that all of the original PDF text that has been uploaded gets parsed. We get all of the text, it gets converted into the different chunks. And then each and every chunk is converted into an embedding. And then we store the chunks and the embeddings into our database. Because if you'll see that the data model here for a chunk is having the chunk itself, that's the chunk data and the chunk embedding. So we store all of that data into our chunks database. And then in order to get the similar chunks, we perform a vector search query where we use this particular function called as the appropriate vector distance, where we check the vector distance between our input embedding and against all of the different embeddings that are there in the embedding array. So for all of the different values, and then we order them based on the distance and fetch the top 5 distances. So basically, the 5 shortest distances are the ones that we will get, and we will pass them as context to our RAG application, which can be defined over here. So here we'll see that we get the similar chunks, and then we put it as joint context. And our Gemini response is here. Now, similarly, if you were to basically use, instead of using a LLM that's an online LLM like Gemini, you could also use an offline LLM like Gemma. So in this case, I set the path of the LLM that's locally there in my database and or in my smartphone, and I can also use that for my use case. So the main idea of performing vector search and being able to store your vectors directly on device is what is happening thanks to Couchbase Lite over here, which has the capability of storing your data, but also then being able to perform your vector search directly on the user's device. And thanks to the capability of being able to like use embedding models directly on device as well, the entire process can be completely transitioned into an offline first capability where right from picking up a PDF document, fetching all of the data or the text, converting the text into the chunks and converting them into embeddings thanks to the sentence embedding model, then storing them and then performing vector search on top of it by using this particular function, which is the get similar chunks, and finally generating a response. All of that can be handled directly on the user's device. And that's one of the reasons why we are seeing all of these different LLMs being uh, applied onto Android or even other types of edge devices. So, of course, this example was with Android, but you can use it with iOS or a Raspberry Pi or even smaller devices if you have much more optimized AI models. And one such way is Google AI Edge, which allows you to deploy AI across embedded mobile web applications by using a cross platform approach. And they can also run completely on device. And here is like another guide that you can follow if you are just interested in getting more into the LLM inference side of things. Of course, this particular conference was the Vector Search Con. So the main focus was how you can run vector search and RAG on top of Android. But if you're just looking to run LLMs directly, you can also do that here. And as I conclude my talk, I just want to say this that AI is truly going to be revolutionizing the edge compute and on device AI models. And at the forefront would be technologies like vector search and RAG, because they are completely capable of being able to interact with your system and being able to leverage the data while not having to worry about it, because all of that will be running completely offline first, thanks to these capabilities of these models that they can do their inference without having to connect to the cloud or to the internet. With that being said, thank you so much for attending, and I hope that you have a really wonderful rest of Vector Search Con, and I'll be excited to be interacting with all of you after my talk. And if you are again willing to connect with me, feel free to connect with me on my X or Twitter, and you can scan this QR code in order to get access to the slide deck. Thank you so much.